Hello my dear students, I hope everyone is doing well. So it's been a lot gap I have taken. So in the previous video, like I was discussing regarding the atomic trends of a S block elements. So we have completed some of the trends and I have given the explanation regarding that one. I hope you find that one useful. Okay, and the last part of that video is the remaining 3 trends I want to study. Okay, so here the reactivity, basic property and the reducing nature. Okay, so here you could see these are the group 1 and group 2 elements, which we're going to call it as a S block elements. Okay, and we were discussing the trends as we go down the group, what happens. So here the reactivity. Okay, so reactivity comes like a chemical reactivity. So we know that the S block elements are metallic in nature and they are highly reactive, chemically highly reactive compared to other elements. Okay, the reactivity, it's because of their size. So as we go down the group, what happens here? As we go down the group, the reactivity goes on increasing. Why? It's because the atomic radii increases. Okay, the size increases so that the outermost electron are left free, and what we can say, the metallic bond decreases. I mean, the strong metallic bond will not be present. So if the electrons are free, obviously they'll undergo the reactions very easily. So that as we go down the group, the chemical reactivity increases. Okay, so what the order I can write here? Lithium followed by sodium followed by potassium followed by rubidium, cesium and the francium. Okay, so that means what? Here the cesium and the francium are highly reactive compared to other elements. Okay, similarly come here for the second group element, that is barium, magnesium, calcium, strontium and beryllium and here barium. Okay, so as we go down the group, reactivity goes on increasing. Okay, yes, similarly come to the next property, that is a basic property. Okay, so when we say the basic property, so what we can say, according to a Lewis concept, or even you can call it as a Lewis concept, the bases are those which are the electron donors. Okay, so here what happens, as we go down the group, the size increases, the atomic radii increases so that the outermost electron are left free so that it can be donated very easily. Okay, so it can be donated very easily, the outermost electron are very free. Okay, so that's why they act as a good Lewis base, or the basic property goes on increasing as we go down the group. Okay, so lithium, sodium, potassium, rubidium, cesium and the francium. Okay, similarly barium, magnesium, calcium, strontium and the this is beryllium and this is barium. Okay, so this is what the trend of a basic property. So next one is a reducing nature. So what do you mean by this reducing nature? So reducing agents. Okay, these specially we could say that these what S block elements will going to act as a strong reducing agents. Okay, so reducing agent is the one which will undergo a self oxidation. What do you mean by oxidation? It is the loss of an electron, or what we can say, the addition of oxygen or the removal of a hydrogen. So as we go down the group here, what happens? Reducing nature means it will undergo self oxidation, means the electron it will going to lose. Okay, obviously how they are going to lose the electrons? If the size is large so that the outermost electron is free, then it can give out that electron very easily. So that as we go down the group, the size increases so that the outermost electron is left free so that it can lose the electron. So that's why it acts as a strong reducing agent. So as we go down the group, dear students, what happens? The reducing nature also increases. So we could say here lithium followed by sodium followed by potassium, rubidium and the cesium. Okay, similarly beryllium, magnesium, calcium, strontium and the barium. So these are the properties, the remaining property of a S block elements. Okay, so in the next video let us discuss about the trends of a P block elements. Okay, so from a group 13 to 18, let us discuss each property in detail. Okay, I hope you find this one useful. Thank you.